easiest way to code a binary search is to use bisect. So let's have a look at some simple coding. Compare binary linear search or random numbers using a timer, and then explain the difference in certain approaches of left and right. Even show you how to code a solution to an interesting task. And yes, it does produce different results. For those interested, we ask the question, is there more than the binary search? And don't worry, if you just want a simple explanation of linear and binary searches, then that's in here as well. Now it's a lot to take in, but definitely worth watching until the end. Now let's briefly explain linear and binary search, and then we can start coding. Perhaps the easiest way to describe the difference between a linear search and a binary search is imagine you had to guess a number between 1 and 100. Now, first, if you said each number 1, 2, 3, 4, 5, 6, 7, etc. up to 100, you would get the answer correct, but you might have to make 100 guesses. Now, if you was told higher or lower, you could make attempts, such as saying 50, it's lower, 25, higher, 37, lower, 31, higher, 34, lower, 32, higher, 33, correct. So that was 7 guesses, not 100. So it's better using the second method, and that's the binary search rather than the linear search. We're going to import random because we're going to create 100 random numbers. And we're going to use numbers from 1 to 100. Here you can see the list. Now we're going to go through that list, and each number we're going to try to find. We can simply use a while loop just to go through each number until we've found the number we're looking for. So you can see we found these random 100 numbers. Now how many times does that take? Let's create a counter. So now when we print that counter, you can see. Now we want to make sure we have the correct number, what we find, and we can print how many operations that will take. So when we run that, we can see it's going to be roughly about 5,000 operations. We can also use time to measure how long that takes. So let's create a clock, a timer, so we start it before we run our code and end it after. And now when we print our operations, we can also print how long it will take. So let's look at milliseconds and change this to stop. So now when we run this, you can see we've got the time as well, about 0.7 of a millisecond. Now let's look at the binary search using bisect. So we create a list of the 100 numbers that we're going to look through. We're going to use a for loop because we want to go through each of the 100 numbers, and we're going to use bisect to find the number, and we're going to use our timer again, so a second timer, to measure the binary search. We compare the times and you can see there's a huge difference. Now we've demonstrated using bisect, but we haven't explained it. So let's have a look, and specifically the difference between bisect left and bisect right. We start off with bisect left. We've got a list of numbers with several 2's in there, and we want to insert another 2. Now with left, we want to insert it into the first place it should go in the list. So what's the index where the 2 goes? Well, that's going to be at position 1, as if we input the 2 there. Now bisect right, we're going to insert the 2 at the end of the other 2's. It's the most right or last place we're going to insert it. So that's at index 5. So left, the beginning, and right at the end. If we just use bisect, it's going to put it, in this case, the index 5. Here's an interesting task. We want to compare trying to find a number that has 4 digits and compare that to trying to find the same number, but this time with 2 digits twice. So the first 2 digits and the last 2 digits. So we want to compare how long does it take to find either one, using our searches both linear and binary. We start off creating the code that gets the 4 digits, which is a number less than 10,000, and we're going to use a for loop to create them, but also we're going to get the 2 digits, the first 2 and the final 2. We then put the 2 digits into arrays y and z, and if there's no number we put it to a 0. So we can print that and you can see we've either got the 4 digits or the pair of 2 digits. So we add this to our code and we change our code from 100 to 10,000. So we've got a random number with 4 digits up to 9999. So we change that for our linear search and our binary search with our existing code. And now we add virtually the same code, but we want to search for 2 100s rather than the 10,000. So in the binary search, we have 2 while loops, and then we have using 2 bisect, we have 2 binary searches, so 2 linear searches, 2 binary searches, and now we compare the times. You can see there's a big difference with the first search. So a huge difference in time with the linear search from using the 4 digits to the pair of 2 digits. It's a huge time saving. But certainly we would have to consider this approach of splitting up digits if we want to make the search more efficient, or if we was dealing with, say, security, to actually use a longer number so it would be harder to find the password or the code. Well, the binary search is great, but is it the best? Well, perhaps not. If our numbers are being updated, they probably already are in order with just a few exceptions. And we can take advantage of that, for example, in an interpolation search. So that could end up more efficient than just using a binary search. Another example is fractional cascading. So here we've got multiple lists that need to be in order. And here we can use the order of the numbers and links between the list to know where the numbers are in order. Yes, it sounds a bit complicated, but we can use those links. So then when we want to find the number, we can find it more efficiently by using fractional cascading. We can use the existing code in this example to find where 50 would be in any of the lists, and you can see the output. We have the index of the 4 places that 50 would go in the 4 lists in the example.